Yes.
Okay. Thank you, Doctor.
Right. Okay, so generally speaking, yesterday we discussed a little bit about this. You have the user program, and then the user program is given to the master. Okay, that's something that we discussed yesterday. The master receives the job, and then it will assign the jobs to the different workers. Okay. And since, well, then of course you understand. What happened? Of course, you understand that this user program, well, in terms of technical aspects, well, it's forked into different processes that are executed by the worker. Okay, so that's the idea. And then here you remember that you have the intermediate data that are stored in the file system, and then again you have more workers to execute the reduce phase, and then the output. So fork, worker, file system are and job are the key concepts when we think about execution of such kind of solution. Okay, so it's important to bear in mind. And now, so well, that's sensational, but then what happens? What do we gain about this? Well, the thing that we gain is that sometimes, that we know because we have been using computers for a long time, is that the world is not perfect. And some processes fail. So if a worker fails at some moment of the pipeline, we have insisted on this, is that the infrastructure, the engine, will take care of this and restart the process or allocate the job to a worker that remains active. Okay, and so this coordination of the general execution of the job is not done by us, it's externalized into the engine. And I keep insisting that one main difference, and this is why we consider that MapReduce execution environments simplify the problem of executing programs in parallel, is that if we do not use this, it will be our responsibility as programmers in order to deal with failures and decide what to do. Okay, so it's only if we were implementing a Hadoop engine that we would have to care about this, but if we are just users of the engine, we do not have to care about these problems. Okay. And then what happens if the master fails? Because the workers, it's fine, but now the master will lose the pilot of the plane. Well, the engine will take care of that too, okay? It will choose out of the available nodes of the cluster another node, and it will name it master. Okay, these are protocols that are known in distributed algorithmics, and that are applied here in order to resist both the faults of the workers and the faults of the master. Okay, in your case, what you must be sure about is to understand and be able to enumerate the implications of having workers failing and having masters failing, and what are the activities done by the engine in order to address these problems. And of course, make the difference between what is delegated to the engine and what is responsibility of you as users of the engine. Okay? From the point of view of the engine, you are final users. right? So at some point, we are all also final users of different. Do you have questions here? Yes, please.
Yes, I have a question regarding the fork. Well, it does that. It says fork and it goes to the worker, master, and worker. Does fork mean it copies the program in those nodes?
What happens if the worker fails? Is that the question?
No, the fork. It's just that in the image
Ah,
there.
the fork. In
Yes,
fact, you have a program, and now you have a program is a process at execution time, right?
yes.
But you have to you want to the same program to be executed in several workers. Okay, so what you are doing is a fork that divides the process into several instances that are allocated to the workers. The idea here is, I mean, if you think in object oriented, you will only see the several instances of the same class, and these instances are allocated to the workers. But the MapReduce engine doesn't only think about object-oriented solutions. It can think, for example, about C or C++ or Smalltalk solutions where you do not have the notion of instance of something. And what happens is that out of a job, you do a fork and you create the same process, I mean, several processes of the same program, and you allocate them to the workers.
Okay. So we have a program that we fork it into the master, which also distributes this program.
It's distributed to the workers.
Okay.
In fact, these are two times. The first is having this here, or eventually having a user program forked already to the job and to the master and to the other workers, because well, here you have the full experience. The workers can be master at the same time, so you can have several masters. So you can forget this and think simple. First of all, when you have a simple setting, you have the master. The user program is forked into the master, and then it assigns the several instances to the workers. Okay? So that's first step, simple version. And then more complex version is that the user program can be forked into several processes that are assigned both to the master and both to other workers that can act as hubs, as masters, and so that they are again distributed to other workers.
Okay.
You see? But
Yes.
so if I mean, when you have a cluster of several nodes, then you can connect clusters with clusters. That's a data center, clusters of clusters of clusters, or the racks. So when you have this complex setting, you have to have a generic solution for all this, such that from the point of view of the programmer, you do not see the pieces. Okay, you see the computing environment as, of course, you know that there are different nodes, but this is coordinated by some head. Okay, and you only interact with the head. And this is because we want to simplify. Okay, this is only the Hadoop engine. If we are using, for example, HPC, but without Hadoop, then it's our responsibility to do that. Okay, we won't be using HPC here. That you will do. No, you will not do because you didn't choose the selected topics of parallel programming. Shame of you. But in that course, you would have seen how to get rid of Hadoop and do the hard heavy lifting on top of HPC. Other questions? I'm not sure what time is it. Uh, okay, so I'm out of time, but I will conclude now. So just to tell you that this is publicity, okay? So um, there have been when Hadoop start engines have started to emerge, they wanted to make sure that the solution was interesting. Okay, so normally in general, in order to test algorithms, you know that there exist benchmarks. Okay, so there were two benchmarks used in order to test the viability and interest of the Hadoop and MapReduce solutions. And so the benchmarks were grep, that you already know because we have tested it and studied it in the lab, and then sorts. I mean, something that we learn in algorithmics and that we should never forget is sorting algorithms. And so sorts were used in order to test the idea, and well, with 1K, almost 2K machines composing clusters, okay, really at scale. And so what was seen is that at some point, when the input increased a lot, then time increased also. But then once the solution was stabilized, then the execution time decreased a lot. So this means that at some point, but that's an algorithmical result known in parallelism. Okay, so there are limits until which you can get benefits from parallelism, and then when you go beyond, you can decrease the performance. Okay, so all the objective of the solution is to determine in which conditions you will get the best out of the solution that you propose. In this course, we will not get until that because, I mean, we have just started to introduce the model. You are still learning how to organize your ideas into these kind of aspects. So we will not go into the benchmarking aspects. This normally belongs to advanced courses in master degree. Okay, so um, this is not for an undergraduate teaching, but in education. But you have to make sure, however, that you are able to implement your programs, run them on top of the environment, and make sure that you are performing correctly. Okay, so correctly meaning that it takes less time to execute in centralized than in more time in centralized than in parallel. Okay? So that's the thing that you have to consider. So again, an interesting exercise that we could do in the lab is that, no, implementing the grep, for example, in a centralized manner, and estimate the time, and then go into the parallel version and see the time and see whether we are really gaining or we are just doing painful activities without any gain. That would be an interesting thing to do. Okay, so questions until here. So as I said, I will go to the Google Doc, I will comment, I will come back to you with feedback, and meanwhile, we will continue with our map reduce and parallelization problems. Yes, please. Questions?
No, it was just me saying that.
Okay. No problem. Excellent. So if you do not have further questions, I'm going to start sharing my super diaporama. Remember that now even this and the one that I will use in the next session are already online. Okay, so that eventually you can even take notes and then make sure that you have everything necessary to do your exercises and study, etc. Okay, so we are going to close here. Have a nice weekend. Have a nice Saturday, and I'll see you on Tuesday.
Thank you, teacher. You too. Have a nice weekend.
Same to you. Bye bye. Please, Alexander.
Thank you, Doctor. Excuse me, I had a few questions about the homework, and I want to see if you could help me in this last minute.
Yes.
Thank you.
What are the
Um,
questions?
with respect to the UML component diagrams, I wanted to see how detailed I had to be, and for that I want to ask. For instance, I took into account components such as, say, firstly Google Cloud, and within Google Cloud there's a Google Colab subsystem, and composes of a CPU, RAM, disk, the Google Drive storage. Um,
Well, that's the technique. I mean, that's the working environment. Or I was rather ask that you can keep, but I'm also asking about the processes that are running to execute the MapReduce program.
Okay, that's yes. I believe there were two diagrams. One about the two MapReduce count word programs, and one about the Hadoop environment installed on
Yeah.
Colab.
So the one that you are describing me now, it's the Hadoop environment,
Yes, exactly.
right? Yes.
It's the all right. So, and also, for instance, I also added. I don't know if, but I don't know if I should enter so much detail. Let's say the terminal, the file
As much
system.
details as possible. As
Oh,
much details as you can, because this will let me know that you can go into a fine-grained observation and understanding of the environment.
all right. Okay, and okay, that's for the Hadoop environment. And
Yes.
for the two MapReduce count word programs, say I was thinking, should the component diagram should be including, say, the input files, the map is the workers, is the user
The
program
workers, the master, the file system.
system. Okay, is the okay, right, is the user workers masters. Okay, and yes, I shouldn't say the components I include in the two count programs shouldn't be necessarily the same as from the Hadoop environment, right?
No, of course not. The
Okay,
environment is over there. The environment can be seen as a box, you see,
mhm,
because the environment is the one that you are going to interact with um, in order to execute your programs. But this is a kind of meta modelization of the thing. So to make it easier, you can forget about the environment and just show which are the processes that are running in order to run your programs. And just a comment, you are doing not two counts. The first one is grep, and the second one is count words.
okay. First one,
Mhm.
okay. Very well. Those are the two we have to include the diagrams.
Yes,
Okay, very well. All
good,
right then. Thank you very much,
excellent. So
doctor.
you're ready to go. You're welcome. Bye bye.
Have a nice day. Have enjoy your weekend.
Same to you. Bye bye.
Thank you. Bye bye.